Tree Diagrams by Nick Pistacchio, Daniel Spieler-king, and Mike Aper. Tree diagrams are a helpful visual aid for solving a complex probability problem. This is an example of what a final tree diagram might look like. But how do we get there? First, you start with a problem. Let's say you love Italian food, but eating it for dinner depends on who is cooking. The probability of your dad cooking Italian is 0.7 out of 1 and 0.4 for your mom cooking Italian. And your dad cooks 7 out of 10 days. First, you start with the probability of who's cooking. Now, it's out of 10 days, which makes it really easy for us to find that kind of probability because we can simplify it. Now, 7 would simplify to 0.7 out of 1, and 10 would simplify to 1, so that would make 0.7 for your dad and 0.3 for your mom cooking. Next, you decide what they would cook. Now, you take the 0.7 from your dad, and that would go up to the 0.7 yes, which was stated earlier in the problem, and 0.3 would mean it would be no. Now, if your mom was cooking, it would be 0.4 for yes, and that would make it 0.6 for no. Next, you multiply the probabilities, or the branches of the tree diagram. And you would take the 0.7 from your dad cooking and the 0.7 of yes, he's cooking Italian, to get 0.49 or 49% that he would cook Italian. After that, you would multiply out the rest, getting 0.49, 0.21, 0.12, and 0.18. Add those all together and it should equal 1.00. And just like that, you can solve probabilities with ease. In this particular problem, the probabilities would add up to be 61% for yes, you're eating Italian, and 39% for no, you're eating Italian out of 10 days. The end.